All right, so Eugene is going to talk about jsCoFE, and when I asked him to come, we met several times, but most recently Anat organized a wonderful CCP4 workshop. It was about a month and a half ago or so, 2 months ago, in Beersheba, and we spoke in the same session, but I liked his talk more, and so we talked, and then I suggested maybe he could come back to speak to you here about some really exciting new features in CCP4.
I would be pleased.
Oh, happy. Go. Please. So, thank you.
Yeah, thank you, Joe, for the nice introduction. And indeed, today's talk is about CCP4 solution for distributed crystallographic computations, which is slightly confusing all because I'm going to be speaking about something not released by CCP4 yet. But it's going to be released, pre-released in nearest couple of months. You can use it right now in test mode. This is what we will be going to be to do here, and you can continue to use it after this workshop. And I came here with a sort of selfish purpose to see your reaction to this software. Is it moving in the right direction or not? Are you happy or not? Are you irritated or not? And this hopefully will help us to create something better than what we were creating before for our users. Right. So do you know what is CCP4? Probably you do. But it is not a firm producing software. It's a collaboration. And I lead a group which are software developers and maintainers, mostly maintainers. And, you know, when you speak to people generally about software, they say, oh yeah, develop a program like Phaser or FMAC takes a lot of effort and maintenance. What it is? Compilation, well, must be trivial. Distribution must be trivial, but I can assure you it is not quite, because every computer is now individual. They have their own software, which clashes, installed, and so on and so on. And each time operating system has an update, we, the maintainers, get anxious because we don't know what kind of surprises it will bring to us. CCP4 would normally stay okay, but sometimes it crashes and we need to investigate. So we are very much interested to see what is ahead of us. And for this purpose, the best forecaster so far were the 21st Science a studio from Hollywood, who delivered to us that our future is the matrix, if you remember it well. And the matrix is going to be ruled by three mighty lords, Microsoft, Google, and Apple, who will control everything through a zillion of network connections for remote access to everybody's brain and so on. And if you want to deliver your software in such a hostile environment, what do? You have to be the one. You're on pair with the lords. You need to be the part of matrix. And this is how the issue about remote computations in the maybe not so remote future comes about here. Speaking seriously, indeed, we had a series of motivational points for stepping into this area. Crystallography, computational crystallography, and crystallography in general has been through significant progress during last decades. And I think personally that a structure solution has become a more pleasant experience for users thanks to many automatic structure solvers which came about. However, nothing comes without a price, and these new solvers are resource hungry, both in terms of disk space, databases, and CPU power. Just an example, those are selected automatic solvers from CCP4 distributed these days. Mr. BAM, this automatic solver for molecular replacement, it takes from hours to days of computations in CPU-wise term. Balbius, well known for running at CCP4 from 2008, I believe, as a web server, also takes from hours to days more. This is a new, much advanced version of Balbius, so to speak. Also hours to days, crank to our new and quite a mighty one pipeline for experimental phasing. You just give it MTZ and it's all structure for you. MTZ and sequence, and it's all structures for you. Hours to days again. Ample is an instrument for ab initio molecular replacement. Ab initio means you cannot find a model in the PDB, and then you want to synthesize it somehow, computer-wise. And Ample does it for you. It looks for a model starting just from sequence, takes your MTZ and tries to solve structure. That takes from days to weeks computational time. And SIMBAD new pipeline for molecular replacement without even sequence. It takes just the MTZ, it finds analog in the PDB by checking on a translation rotation function of known PDB structures, and it takes from minutes to hours, which is not that much, but still a resource. So resource is the first motivation. You want a server to run in this application. You don't want your laptop running for days and weeks. No, you need a server. Second motivation is, mobile and cloud computations are already around us. Who does not use services like Gmail, Yahoo, and anything for emailing these days? Raise your hand. Everybody does. And there are many other services like this. So it is all around us already. Apple Cloud, Google Cloud, Microsoft Cloud, Amazon Cloud, they're all there. Why not crystallography? It would be very nice, I think, if CCP4 could be used on any device, from smartphones to tablets and then PCs. It's not a fantasy. You can do it already today. Really. And if these interfaces on all these devices would look absolutely the same. And you don't transfer data from your smartphone to your computer. It's all there in the cloud. Wouldn't be nice? I think it will. Of course, there are issues like data security. Well, this is always an issue, whatever you do these days. You need to specify your place of birth and date of birth for declaration form in SRF. So data security is everywhere. Solved by running local clouds or special security clouds and so on. Bandwidth limitations, yes, but this is subject to implementation. Third motivation, the maintenance. As I mentioned, CCP4 is mostly about maintenance of software these days, not so much about new developments. And we distribute 5 versions of CCP4 for 3 major platforms, macOS, Linux and Windows, 32-bit, 64-bit. And the associated burden of building, packaging, testing, updating of all this is quite high, believe me. On a user side, there is a burden as well. Once you install software, you want to update it. And if it comes with databases to solve structure, you want to update the databases, they take place. And even for me, maintaining all the software on my own laptop is a burden without CCP4. So you want to escape this complexity somehow. And if any significant fraction of online computing be there, a reality, then I think it would decrease the overall burden on maintenance, both for us, CCP4, this is a very selfish reason, but also for you, the users. And if development, final reason, is based on common and primitive web technologies, then it is very likely to stay for a very long time, because HTML world is very stable. Vendors of HTML cannot afford their websites to collapse overnight because of strange update or something happening. So HTML has very strong legacy, much stronger than any desktop environment, believe me. HTML is there forever, in true terms. Or at least there will be backward compatible solutions for HTML. So that's enough for introduction. In 2 words, this development has been done already, and it is available. And this is how schematically it looks like. So we got a front-end server to which all devices like laptops, smartphones, tablets, anything which can run common browser, without anything, just common browser with OpenGL, by the way, can talk to. On the other side, the front end can talk to facility like Synchrotron to fetch data from Synchrotron to the system. It can also talk to arbitrary number of computational servers to run computations for you. This is the basic idea. And currently projects and data storage are on the server, but ideally it should be also somewhere in the cloud. So blue lines are HTTP connections, and this makes difference of this setup from ordinary web server. Why? So this particular architecture has a few interesting basic features. The users see it as a website or as a web application. Nothing unusual or uncommon from this side for them. But computational nodes may be individual clusters or individual workstations or clusters subject to configuration. And optional servers can also run on client machine to assist using packages like COOT and some others which are not made online yet. We work toward online versions of them, but currently they should be launched in a slightly different way. And there is no principal restrictions on the number of servers. They are all HTTP connected, therefore they can be anywhere. If a Saudi Arabia king wants to donate us 1,000 CPUs, we can plug them in without going to Saudi Arabia. That's very easy. So this system is ideal for collaboration, for crowd resourcing, and if not bureaucratic barriers between countries and institutions and so on, it would be a very nice setup. On the other extreme case, all this server can be put on a single machine, like your laptop, and then jsCoFE works as a mere GUI interface to CCP4. So all kind of flexible configurations is possible. You can run it as a local GUI, starting jobs in the cloud, or as a website where GUI runs also on the server, but accessible to you via ordinary browser. That's enough about technical side. I'm not going to burden you with implementation details. That's just the idea. From the user perspective, as I said, it's a website starting with simple login like that. You can recover forgotten logins using second button and register yourself free of anything currently at the third button. When you log in first time, you will see a list of projects, initially empty. These are your projects. Then you go to that menu and go to My Account, where you can change your credentials and password, which is more importantly because after registration you are given a random password, so you change it to whatever you like. Then you can go back to a list of your project and create a new project using a couple of buttons, add on top of it, or if project is already there, you just double click on the corresponding line, and this is how a typical project would look like in this system. So firstly, jobs are not ordered chronologically like in conventional interfaces CCP4I or I2 or even in Phoenix, I believe. They are arranged into logical trees, and this tree is reflecting the actual data flow from job to job in your project. That's why I think these trees are much easier to reconcile years later when you write or months later when you write a paper about a structure solution and you wonder how it was actually solved. I got 1,000 jobs in my CCP4I or I2. They are chronologically listed, but now I have to remember what I did. Phases from here, structures from there, and so on and so on and so on. In tree, it should be, I think, easier. Which button do I press? Probably the error button.
Maybe it's off.
Still, sorry.
Which one? This one.
No.
This one. What?
No. To
Pointer,
Dima.
the
Oh,
pointer.
Beamer.
Dima. Oh, this one. All right.
This.
All right. Yeah. Sorry.
That's it.
Yeah. The Dima. So you can see that we imported data, probably one unmerged MTZ file sequence and a PDB file, XYZ. Then we did some ensemble preparation, probably for molecular replacement. Then made a ligand, probably to fit later on. Oh, sorry. All right. And then ran aimless. For anybody knowing CCP4, it means data scaling and merging. And then defined content of asymmetric unit of our system. Then ran molrep and refmag, then model building with Buccaneer, and our factors were still high. Then what we did, we got an idea that this is an antiomorph and changed space group, another branch of the project. So now it's a branch. molrep, refmag, Buccaneer, again high R factors, and we branched again. Now we decided that we want to correct the model according to the sequence, according to this annotation. Did the same, and our factors became much more reasonable. So refinement again, then fitting ligand, running COOT to correct ligand position, I guess. And then it came to final refinement, and it was good enough to run analysis software like PISA or Gesamt for finding similar structures in the PDB. So this project is, I think, much easier reconcilable from just the annotation of the tree than anything you can find in at least CCP4I or I2, especially when number of jobs is very high. And if you double click on any job, let's say on a RefMark job, then you will see picture like this, with sometimes lots of graphics, sometimes nothing absolutely, because system is still in progress. But specifically here, you can see the dynamics of R factors, and you are satisfied because it came to the plateau, does not diverge, so refinement was reasonable at least. Here the buttons to call different viewers. If you click on this one, Ugly Mole, then it comes up in your browser with additional pseudo window. Electron density and structure solution is there, and you can get it, I repeat, on smartphone, on a tablet, Android, iOS, doesn't matter. It's just the browser. Whatever can run browser can run this system without anything else. And yes, this is a reasonable fit. Even ligand here, you can see it stands quite reasonably, and so on. So now, we will consider this all in much finer details tomorrow at tutorial. But now I want to implement in you a couple of ideas without which the system may seem to be not perceivable, not working for you straight away. So structure solution in jsCoFE follows the very normal route for a general structure solution. You import data, then you do some data preparation, depends on what data it is. But then in jsCoFE, you must have a symmetry hypothesis to choose the space group, basically. And space group remains a hypothesis until structure is solved. This is one interesting point. Secondly, you have to make hypothesis about content of a symmetric unit. And it's also a hypothesis until structure is solved, strictly speaking. In most cases, these hypotheses are not difficult to make. But sometimes, especially when you have an antimorphic space groups and so on, or higher, lower symmetry groups depending on cell dimensions and so on, this may be a little bit tricky, and you have to guess. You have to try solution in one space group, doesn't work, try in another one, and this is how difficult crystallographic cases are solved still. But then, after you make these two hypotheses, the system allows you to proceed to phasing, and if phasing is successful, in your opinion, you do model building. Then if you got ligands, you can fit ligands, do final refinement, and run a few analysis tools if you like. And all this is arranged in branched projects, as I tried to demonstrate before, and projects can branch at any state. You can branch at data import, you can data import after any of this state, and branch from symmetry, branch from unit cell. It's completely up to you how you build your project. And it takes a couple of tries to understand how to branch them properly, to make them more convenient. But we hope that couple of attempts is enough to get a good feeling of it. A few words about some other things. Data import. jsCoFE can get data via upload from your desktop or laptop. Or it may acquire data from ICAT facility at STFC, which is connected to ISP-IB and Diamond, and as I today learned, also SRF talks to ICAT to STFC, so these are good news to us. The only bad thing that the data get from ISP-IB to ICAT after 40 days for long storage, not immediately, as I learned from Diamond people at least. But that's just for beginning. I'm sure we can work better on it and get data from Synchrotron very soon after data collection. And you import files, but you cannot work with files in cloud, because in cloud you don't have a file system. You don't have a definite path, so you can't work with files. Therefore, files go through a special import procedure and become data objects in jsCoFE. And data object is not necessarily like data object equivalent to MTZ file. No. MTZ file can contain several data sets. Each of them becomes an object. A sequence file can contain several sequences, and those become individual objects, and so on. On the other side, when a structure is partially solved, we have coordinates, sequence, and phases related to each other. So it makes sense to make them the object. And this is a bunch of files. Sequence, phases, even reflections. This all relates to a partially solved structure. So this is the object there. jsCoFE works only with objects within it. You see files only when you upload data to jsCoFE and only when you offload data. Then you see files. So speaking about data objects, we have just 7 types of them and a special convention on naming. Naming must be unique because you need to differentiate different same objects of each other produced in different jobs. Therefore, the convention is first is wrong button pressed. First is job number. That job may produce several objects. Therefore, serial number within the job. Then name, which will be assigned by default, but you can provide your own custom name for this part. And then type, subtype. Just for clarity, when you see such an object in a menu item on input to the task, you can quickly see, is it anomalous data? Is it sequence? Is it protein structure? Whatever. We will see it later. Then second important type of data, but not exactly data, are revisions. Not a very successful word for it, but nobody can suggest better than that. Revisions should be seen as a box where you put things, various things, which are related to particular stage of your structure solution project. When you advance to new stage, some things get replaced with new things, and so on. But these boxes stay along the project tree in place of jobs. You can always revert back to a job in the job tree and start again from the same revision, from the same box, like in software revision, software repositories or database. So it's a mechanism for rolling back and checkpointing your projects. They name it similarly to data objects, but we put R, capital R, to say that this is a revision. So then, in general, for the data logistics in jsCoFE, any job can see data from where it is and up the corresponding branch of the project. For example, job number 5 can see 8 can see data from job number 5, 4, and so on. But job number 15 cannot see data from job 9 because it is in a different tree. What it helps you to keep input data to individual tasks in a very laconic lists. If you generated 1,000 data sets during a very branched tree, not all of them appear in drop-down menus when you select data for a particular job, because most of them are irrelevant to what you are doing in this particular job tree. But sometimes you need to merge data between the trees, and there is a mechanism for that. But let's not concentrate on this. You can merge data from different trees. Right. Then next thing, job logistics. You add new job to an existing one by simply pressing button plus, add job, or this button for inserting job. You can insert one job between others too also. Right, and then automatically a task list pops up, and first up are suggested jobs. We made a trick, and this tab is actually learning your habits as a user by analyzing configuration of job tree, and then it sees which jobs you are more likely to run after a combination of other jobs in your practice. And initially, you are given with very few suggestions here, but gradually it populates, and hopefully this is our game with you, the users. You will feel more comfortable because you don't have to go to full list each and every time. In many cases, after a certain number of trials, we hope that in 90%, 95% of cases, right job will be in this much shorter list of suggestions. But if desired job is not suggested, then you proceed to full list, which is arranged in foldable directories like you normally see in CCP4I or CCP4I2. But there is also a difference from more conventional interfaces. You can see that first let's say, in this experimental phasing tab, at this point of the project selected, no jobs is available, 0. You don't have to look into it. You cannot run anything from this section. But let's say you are desperate and you want to run refinement at this stage. Refinement on what? I don't know. There is no file here, but suppose you want. You open this tab and see that buttons for ref mark, for anything else in this session, are in red. Traffic light, red, boom, you cannot go. Not exactly that. You can go. You can press on this button, and then what happens? The system tells you, no, you can run this job. You cannot run it because you don't have a revision cross. It takes optional coordinates for low resolution refinement, but which are optional. Therefore, they are not in the system. But no, they are in the system. Uploaded one up to that. But you need a revision, and then you wonder what the revision is. But here is a suggestion. You can click here or there and read some help and educate yourself. Particularly, it says that structure revision missing. Perform phasing first. There is nothing to refine before you phase at least something. So we hope that the system is more explanatory and more understandable if you dare to read at least something. But saying this, I'm guilty as a sin, because not all documentation is yet written. But it will at some point. It takes a lot of word and good knowledge of English to write good documentation, right? And all this we lack in CCP4, like in many other places. Right. But if job can be run, then clicking on such a button, which will be in green or orange, you will be presented with a task interface, which is conceptually similar to task interfaces in CCP4I or CCP4I2, only they are much more laconic, because most of the data... Oh, sorry. Oh, sorry. All right. Because most of the data is passed through only one item, the structure revision. If you produce one job as a child of another job, then obviously you want to take data which was generated in that job, and possibly the data above, like reflections which you imported a few jobs above. So this is so natural. There is no need to specify output from this job, and then reflections which were up there stream in your project, and then sequence again, and then free R flag again, which is required in CCP4I2 and CCP4I. So all the specifications is grossly redundant, and we tried to collapse this in just one line here, revision. And in most cases, it will be just one revision, because it is sent from a job which normally generates one revision. It may generate several revisions in some particular instances, but most often it will be just one default. Then you check all other parameters and data. Let's say for low resolution refinement, this interface takes optional coordinate models for generating external restraints. But generally, you specify a number of cycles if you want something else in RefMark interface. Run this button, voila, job is done. So I think it should be enormously more easy to make new jobs, and there is also a danger in here because people think less. If it is so easy to run a job, especially not on your own laptop but on server, you don't care about electricity bill and CPU. And indeed, some users, some test users, they can start 200 jobs a day. Gosh, they all run in parallel. We are happy, yes, but such a waste of resources will need to be mentored at some point. Right, this almost concludes my talk. I would like only to mention the current scope of functionality of this system. So what we got routines for data scaling and reduction, which is obviously pointless, aimless in CCP4. We got almost a full set of molecular replacement routines from CCP4. That's phaser molrep and automatic pipelines Balbes, Morda, Mr. Bump, Simbat. Not Ample yet. Ample is so resource hungry that we don't dare to offer it to just everyone, sorry. Experimental phasing, which includes Shellex, a phaser again, and on automatic side, a Crank 2 pipeline, which is highly recommended. In general, I would encourage you to try automatic methods first. If they give you nothing, which is the case in about 30% of cases, I believe, on total, then you start to work stage by stage and see what's wrong. But automatic pipelines can give you already a hint what's wrong. For example, cannot find the model, then you need to have a manual attention. Or in experimental phasing, ShellXD doesn't find a substructure. Oh, then maybe you need to bring in protein phases from somewhere from molecular replacement and combine them. So automatic methods can give you a good guess, even if they don't give you a solution, but they give you a good guess how solution may be acquired in future. So then we got density modification, currently only Parrot, but this is quite a robust and good method. Model building, automatic pipeline, Buccaneer, highly recommended. And of course, manually you need to build residues which cannot be put by Buccaneer automatically with COOT, or correct what Buccaneer has done for you, also with COOT. And COOT is jovial in CCP4 functionalities, so of course everybody knows about it. Then ligand and water fitting in structures, also COOT, both in automatic and manual regime. Refinement, not just refinement, but complemented with low resolution tools like ProSmart to generate external restraints for low resolution refinement for FMAC, and Lorester, which does automatically generate restraints and run the refinement, and then RefMark in different modes, and then tries to use to find the best refinement protocol. Actually, Lorester is recommended for final refinement as a first tool, not for intermediate refinements, but for final refinement. Validation and analysis includes currently COOT and PISA software for identification of oligomeric states, protein oligomeric states, and some small toolbox which currently contains only structural and sequence aligners with Gesamt and Cluster W. And also, as an experiment, we put a new automatic pipeline into CCP4 called CCP4 Go, which is supposed to take it from unmerged NTZ and sequence down to ligand fitting. And tomorrow I will demonstrate how it works, at least in one case. Because normally ligand fitting is a difficult procedure, but sometimes it works. So why not try it? Even if it doesn't work on ligand fitting, but has done phasing and refinement for you, that's already a good result. Speaking about current state of development, it is, as I mentioned, in a pre-release state, and first release is going to happen in nearest months. Now it is delayed by European Directive on Data Safety and Security. We have to do some things on server to adapt for this. This is a month's work. And then making HTTPS access to our server. This is a temporary name, but you're very welcome to use it. Not a secured connection, but you're not going to pass us any secured information anyway, I guess. It can be installed locally. There will be a link at this page which tells you how to install it on your desktop, and any IT staff can install it in your lab or even university. You're very welcome to try it. Contact us if you want to do it and cannot do it for some reason. We try to keep it simple and intuitive for user, and please speak to us if this is not the case, because it is intuitive and clear for us, obviously, but not necessarily for you. That's why I said it's a selfish reason to look into your eyes when you look at this and see is it good or not. Test use and feedback are very welcome. And final slide, as always, to acknowledgement to so many people who contributed into this development so far. And particularly, oops, again, doesn't like me. And particularly BBSRC Research Council UK for the research grant, which was supporting this development over the last 4 years. This is all for the introduction. Details will be tomorrow at tutorial. You're very welcome. Register to jsCoFE using this link. You may take a notice of it now to save time tomorrow. But again, Andrei Lebedev, who was on acknowledgement list, is now working hard with local IT to make it available in local setup, which will be slicker. And it almost works already. So we might use our server, but we also might use local setup subject to situation tonight. I hope it will work. Anyway, all right, and I'm happy to take Any questions?
It's really great.
Oh, thank you very
So,
much, Joe.
Great. Are there questions?
What is the abbreviation of jsCoFE?
JavaScript powered. It's a JavaScript powered cloud front end. This is what we wanted to do initially, just the front end. It was a very modest project, but now it evolved into something more considerable because we had good feedback from users and other institutions. We probably rename it. Right.
Is the local installation just the same program running in a web browser? So
Local installation requires having Node.js in your computer. Node.js is Google engine for web services. It is freely available on free license. If you Google on Node.js, you will find a website from where you can download binaries and install it just by copying in your computer. It's absolutely not a problem. Then it requires installation of JavaScript and Python scripts from our repository, and link to that repository and full access is also given at this address. When you, this address will bring you to a link. I should actually show you. Right, you see here, if you click on this link, it will bring you to a page with documentation how it installed locally on your personal PC that works nearly out of the box, nearly. And if you want to set up it for external access, like in a lab or institution, then it requires a little bit more work, but still very much doable.
is there any benefit in using the local installation instead of this web-based one? Or
Local,
local one works without the internet connection?
no, there is no other benefits, absolutely not. Sometimes you don't want internet connection if you're working on sensitive data, for example. So this is first consideration. Secondly, it's much easier to install and try to see and throw it away if it doesn't suit you. Locally, it serves just as a desktop GUI and nothing else.
This number of steps that you do, that can be thousands or as many.
We don't limit it in any way.
Then you'll have a huge stream.
Yes, it will scroll up and down and horizontally as well, like in any other web page.
I think this is much nicer than CCP4 I2.
It should be, yes, but final say is after the users, which tried this and that. Yes, please.
Can you work on the same project using the, whenever you are somewhere with internet access and
That's the whole idea. Once you have it,
you have a local installation, you run the same job.
yeah,
and it
absolutely.
kind of syncs.
Yeah, that's the whole idea of the cloud setup. All your data and projects are up there. You don't know. You can access today. You can you can work from laptop and submit jobs. And tomorrow you can use your smartphone to check on job status.
Well, I meant that if you have a local installation, can different installations talk to each other?
Yeah. Well, you can see these two buttons, export and import. You can import from one installation and import the same project into another installation. It comes as a gzip tarball, so you download this tarball and without any modification import it into another installation, and this is it. Yes.
Can I ask another question? You are using also as a possibility unmerged data.
Correct. And this is advised.
This is advice, but can RevMark use RevMark unmerged data as input?
Not yet. Garip is working on this. Therefore, yes, if you import unmerged data, the first state would be to scale and to merge them.
Yes,
And this is exactly why you run pointless in your projects, pointless, aimless. So this step is exactly for merging and scaling. And then, yes, you can merge and scale into different space groups, and this is how you make your space group hypothesis and branch your project and try this, and
So you have to
that.
repeat this then every time.
If you then want to reprocess into a compatible space group, like here, into different enantiomorph, then you just reindex it. So this job is just reindexing. But if you want to merge it into something completely different, which is also possible, then yes, you have to repeat this job. And this is done very easy. You just focus on this job, you click on this job, and press this button, which is clone job, and just specify a different space group in there. That's it. That's it. Well, sometimes you need to tweak like resolution range, number of batches, and batches which take a selection of batches and so on, but that's about crystallography, not the interface, obviously. Yeah. Then automatically when you focus on this job and say clone, the clone will mean a branch. And this job will be not after aimless, but will go somewhere here and create a new branch there. And then you can see it very clearly in your project. And, yeah.
So why did you call it revision, maybe just not node? In some sense, it's a node or a checkpoint. A node is, because revision means revising from something else, but a node is an option to go here and there and so on.
We are software maintainers. For us, revision is a revision in software repository where it is a legitimate term. That's why. No. We don't insist on it because everybody complains about this word, and I'm happy to talk to you offline to see. Yeah. That's a painful point because yes, people see it's a revision of something already done, but in database and software business, it's a revision. Version, revision, version, revision. Yeah. Sorry, go on.
You said at the beginning that so far you can freely register. Of course, lying here. So kind of resource-wise, if we all start to use it.
Yes. So currently we have this as a prototype. We power it with about 200 CPUs, which is sufficient for today's use, and probably we can take about 200 users more without big hesitation, if they do not work completely in phase. All right, but if everybody, CCP4 is distributed to about 20,000 users, if everybody will start to use it at our web server, then no, we cannot cope with this. That's why it is offered for local setups first. And secondly, we are actively looking for resources like from EGI. I'm talking to them. We are considering Amazon Cloud, Azure Cloud, but then a question of charge and crowd resourcing, as I mentioned, if Saudi Arabia King or Jordanian King would like to donate a few of 20,000 CPUs at Saudi Arabia universities. They have this machine, which is mostly idle, I know this. Then we will be happy to take this help, and from anywhere else as well. Right. Sorry, you are.
Do you see some might be able to import data directly from like Diamond?
To be honest with you, I spoke to Alun about this a few months ago. And we did not advance much since that. I was specifically asking about ISPIB API to fetch data from there. Instead, during this time, we achieved this goal with ICAT, so fetching data from ICAT, which is a little bit diverse route, but I'm sure we can make it from ISBI, provided goodwill is there.
What is really ICAT?
ICAT is a long-term storage for data collected at Synchrotrons. It goes on tapes with a robotic storage. Should be kept forever. But of course, if data is on tape, then request is long. The tape is taken by robot, put into device, and then your request is fulfilled. Therefore, this access is generally slow. Therefore, we cache it, of course, but still it is not as slick access as we could achieve with ISPIB, and this would be very nice to do. We are keen to do this.
ICAT is from UK.
Yes, ICAT is maintained by STFC, Scientific Computing Department, our department in STFC. That's why we have a shorter route in-house than between the institutions.
So in case if you want to use a tool that is not provided by CCP4 in any of the steps, and then input a job from there,
No, you cannot input a job from somewhere. A job needs to be created in this system.
Let's say if I want to refine in Phoenix Refine, and then
Oh, you can download data from here. It will be the same MTZ file and the same PDB file. I will show you tomorrow, and be my guest. Put it into Phoenix, but don't. But cite CCP4 then when you publish it.
No.
Right. Anybody else? Questions?
So I think we take a break, but from this, but you just was really good. So tomorrow you're going to show tutorial.
Yes.
All right, so I think we will continue tomorrow with this, but I think it's a totally different way of looking at this than just.
I hope so.
I've known from looking at all these CCP4 jobs, it looks very good.
Okay. Thank you.
Great. So,
Thank you.
yeah. Really, really good.
Thank you. Thank you.